كسرة ولا زيتها؟ नहीं यार वो सुनती नहीं है उसके पास
Naga Sai Kumar. Naga Sai Kumar, am I audible to you? Naga Sai Kumar.
इसका डाउट तो जा रहा है मेरे ऊपर इतनी गंदी नहीं बनी है समझ में आया ज्यादा तुम बकवास ना करो अरे
Kaushiki Awasthi, please go mute.
ज्यादा मुंह वाला ना इतनी गंदी नहीं बननी ठीक है खाना हो तो खाओ नहीं तो फेंकाओ हाँ
Okay, welcome back, guys. Very good afternoon. Am I audible to you all? Yes. Okay. I think we are good to go with the session. Yes. Is my screen is visible to everyone? So this is how we configured and we came to know how to assign the IP addresses for intraLAN, and we also saw that how the immediate routers are interacting with each other and how a remote router was not interacting with the host device, right? With the end user device, how it was not interacting. So for that, we need to create some intelligence. So if I'm not wrong, I think the section part of routing basics with respect to booting and also path selection, everything has been done by Gaurav. Is all this packet filtering and packet switching, everything is taken care by Gaurav? Yes or no? No, you can't say yes or no because I have received the document from Gaurav once again. I just open the document. Okay, no issues. Fine. So now, anyways, you have witnessed that how to make the router interact with each other, right? So I'll just go with that scenario itself. What was the issue? One second. After closing VM and reopening the project, do we need again write the commands to make the connections? See, if you have saved the configuration with WR command, I think everything will be saved, and you can close the GNS3. And again, if you are resuming back with the same project, it will resume back. Fine. So no need of reconfigure everything again and again. So that is why if you are taking care everything with the notepad, it will be easier for you to append the things, and then and there you will be able to save it, right? So make sure you are doing the things with notepad as I did earlier. Okay, we'll look into that issues again. Okay, fine, no issues. We'll look into those issues again. So 80% success is also a success rate. No issues, because there will be some delay with respect to ICMP packets which are generated. When you ping it, if it is popping up with 80% success, it is also fine. Again, if you ping it, it will lead to 100 success, 100%. Clear? Okay, fine. No issues with that. Okay. So we came to know why router and connecting LANs using router, and also how the LANs are connected between the routers. Everything we have shown. Sorry, everything I've seen. Once again. Okay. So let me go with the concept of packet switching as of now. Okay. So what is packet switching? Packet switching is a term that has been derived to identify the total number of devices which are ready to forward those information from source to destination. Is that clear? So we call it as node to node delivery. So how many nodes are there here? Can you please ping out the figures? Ping me the figures. How many number of nodes are here? 5 nodes. 5 nodes. So when we say how many nodes are there, it is including switch and routers. It is not only with the end user devices, it is including with switches and routers, also the intermediate nodes. So altogether we got 1, 2, 3, 4, 5, 5. So altogether we got 4 number of nodes. For each and every node, how the packet is getting switched from each and every area and how it is getting delivered to destination is nothing but the concept of packet switching. Okay. And how about the inter-network communication? So when we call it as an inter-network communication, of course, we think we should think about the packet that is being generated with, right? So how the packet has been generated and how it has been traversed, right? So which is where the packet actually get birth with. The packet's birth will take place in the source side, right? The packet birth will take place at the source side. Yes. So when the source is ready to transfer the information, the source should transfer to the switch in such a way the switch will accept only what? Whether it will accept the IP address or it will accept the MAC address. It will, the property of switch is only accepting with the MAC address, right? So initially the switch will broadcast for the MAC entry of all the devices which are entered. So how many MAC entry will be the switch will be having here as of now? 2 MAC entry, right? MAC entry with respect to router's MAC address and also host MAC address. Exactly. And again, when the packet is being established between this particular LAN and how it has been interfaced and how it is being crossing over with respect to destination, everything should be accounted. For example, when we see this, both are, one is classful and the other one is classless address. Yes or no? Who need to take care of this forwarding? Who need to take care of this forwarding now? Router, right? Yes, exactly. The router will take the forwarding thing by accounting how many number of intermediate devices are there. Okay, I'll slow down. Okay, I'll slow down. But the router will just identify how many number of devices are there, right? So how many number of devices are mutual for router now? How many number of devices? Will it take the switch also into the consideration? No, right? The switch will be not the counterpart of router, because router is worried only about its gateway property. So who is having the gateway property of router? Who is having the gateway property of router? Host, yes, exactly. Not switches, end user devices. The end user devices are having the gateway property, exactly. So the router will construct itself the appropriate network address only. It will construct, initially it will construct what? Can you see here? Initially it is trying to construct what? Appropriate network address only. It is not trying to map either the source IP or either the destination IP. It will try to construct only the appropriate source, network IP. We saw in the routing table of the R1, right? In the GNS3 tool. Yes or no? Routing table of R1, it was identified with two interfaces, right? Two interfaces and two network address, right? Was it showing the complete IP addresses? No, right? It was mapped only with the network address. It was not mapped with either the source IP or either with the destination IP. It was mapped only with appropriate network addresses which is connected with. Exactly. So next one. The next one. Okay. Again, packet filtering. Now, once the router has got its entry of network address, guys. So what is that? Once the router has got the entry of its network address in its table, so what it will do? Will it check for the network address or it will check for the source destination's IP? Tell me now. Will it check for the destination IP? Yes, of course it will check for the destination IP. So how it is being checked? Once it has been acknowledged by the destination. So the router will be having in its entry saying that, okay, fine, for my gateway, this is the particular party who is connected with this respective address. So thereby, if it is not found, are you getting clear? If it is not found, for example, so now let me take this network now. Let me take this network. 10.0.0.0 belongs to which network? Which side of the network? Yes, it belongs to host one side, right? You tell me the interface, okay? Router's interface. FA 0 bar 0 it belongs to, right? FA 0 bar 0 it belongs to. So what is via? What is via? Via is nothing but, for example, you have planned from, yeah, through, yes, exactly. By the way, exactly. So you are planned for example, if you are planned for London, if you are traveling to London from Delhi, so the flight will hop, right? The flight will hop in Dubai, for example, right? So Dubai will be what? Considered as by the way. Yes or no? Dubai will be considered as by the way. So via Dubai, you are able to reach London. Is that clear? Is the concept is clear? So now to reach from 10.0.0 network, so which is the interface? Yes. Am I audible now? Please let me know. Am I audible to you all? Okay. Thank you. Yes. So with respect to F0 bar 0 interface only, the router will be able to capture this network IP, right? Yes or no? Do you agree? With respect to only this interface, the router will be able to capture this network IP. So if this IP is not delivering this network address, what happens? What happens? If the entry is not there, what happens? Immediately the router will drop the packet. Exactly. Immediately the router will drop down the packet, and this method is called as packet filtering. Is that clear? This method is called as packet filtering. So each and every network address should be available on the routing table. If the router has not that entry for the transaction between source and destination, the router will immediately drop down that packet, and this dropped packet is called as packet filtering. The process is called as packet filtering. You can see from the figure now. It has not attained this network at all. I gave the example of this network, but they have took the example of this network. You can see the example here. They have attained with respect to host 2. I've taken the host 1 network part and I explained. They are given the example of host 2. Is the concept is clear? Okay. So we'll have a recap, no issues. We'll have a recap. Don't worry, we'll have a recap. So let us focus on hands-on. Let us focus on hands-on much. So the path selection. So addition to the previous architecture, can you find the architecture has come a bit changed? Yes or no? Yes, you're right. Yes. Now tell me, host 1 has got how many number of routes to reach host 2? How many number of routes? Yes, exactly, guys. Very good, very good. Exactly. So this is one path, right? This is one path, and the other path is this is one path. So this is called as path 1. This is called as path 1. And to reach here, how many? So this is the other path. No. There is only 2 paths. There are only 2 paths. How come 3 paths are there? There are only 2 paths. Yes. This is one path. Yeah, this total one path. I am just trying to tell you this is the continuation of this path. Okay. This is the continuation of this path. Fine. So now, will it choose the maximum number of path? I mean, the longest path or the minimal path? It will choose the shortest path, right? Yes. So based on what? Based on hop count or metric. Yes or no? Metric is nothing but the cost that are implicitly added on the edges. These are called as edges, the connectivities between the edges, the cost that has been applied on the edges which has been carried out, or the total number of in-between routers. So when this R1 has got the ability to reach the path without having any hop count. So how many hop, if it is following this route, how many hops it need to encounter with? How many paths? How many hops? Sorry. Only one, right? I mean, now the host need to encounter with 2 hops. If it is passing through this path from 1, 2, 3, 5 and 6, if it is passing through, so how many number of paths? It is only one path, right? I mean, only one hop. Only router 1 will be existing. Why is the necessary of router 2 when it is carrying with longest distance, right? So the path selection should be also be accounted as minimal. So these are the attributes each and every routing table should follow with. Hops means, yes, number of intermediate nodes that exist on that between source and destination. Number of intermediate nodes, I mean, usually the routers comes into picture. Number of intermediate nodes that exist between the source and the destination. See the routing table. What are the attributes that you can come across with? One is destination network. One is via, through which interface, and what is the total distance, right? What is the total distance? It has been come across with. So to choose the best path also, it is also a good factor and which will achieve a good amount of quality of service to avoid the delay. Yes or no? Yes or no, guys? Yes, exactly right. So when these kind of situations are there, what happens? There may be a chance of loop. Exactly right. There may be chance of loop. So how the loop occurs, for example, if it is following this path, the host 2 will give an acknowledgement at the time. At the same time, if it is following this path, at the same time, if it is following the two paths again and again, what happens? Router 1 will be completely congested, right? So this is one more scenario. Router 1 will be completely congested because even it has to receive from R2 also, it has to receive the acknowledgement. Even from host 2 also, it need to receive the acknowledgement. So what happens? A loop will get created on the R1. So R1 will not be able to deliver which is the optimal path it has to inform to the source, right? So due to congestion, didn't get it? Okay. Let me explain. See guys, so as we know, there are two paths, right? To reach destination. This is destination and this is source. This is source and this is destination. So when router is the one which is mutual, router 1 is the one which is mutual for all the activity. Do you agree? Yes. Now what happens? Host 2 has received the information with only R1. Now again, back to back, router 1 will also follow R2's route. Router 1 will also follow router 2's path, and again this will also give an acknowledgement, right? So too many number of acknowledgements at R1. Yes or no? What happens? It leads to traffic. Yes or no? It leads to traffic. If the path is not being chosen, I'm talking about, yes, traffic jam. If the path is not being chosen optimally by the mutual router, who is the mutual router here? R1 is the mutual router, right? If he's not choosing the optimal path, he will be completely associated with the traffic. It will create congestion. Clear? It will create the congestion. So once congestion is created, the router R1 he himself will not be able to deliver the acknowledgement to source. So what happens? There will be denial of service. Yes or no? There will be denial of service from R1. Did you got the point? Why path selection is very much important? There are too many other factors. That comes into picture. With it may be the factor with respect to request and acknowledgement. It may be the factor only with independent acknowledgements. So there are too many factors. For this part, please understand how R1 will be on a fixed position. Is that clear? Yes. Exactly. How can we take or decide the path? So that is based on cost. That is completely based on cost. So in static routing, this kind of situations will not be able to solvable. These kind of situations are not able to solvable. So that is why we need to go ahead with dynamic routing. I'll tell you what is dynamic routing is all about later after. First of all, we'll go with static routing. Is that clear? Yes, router is the one who will decide the path. Clear? Yes. Okay. So now let us go back to, I think it is completely the router basics also, the components of the router also has been explained. We've seen much of it. Got the videos of modes as well. Okay. So now we are into the section of 1 second. Are you able to see the drawings? Are you able to see the drawings? Yes. Okay. Thank you. It's quite disturbing with that WebEx annotation. Okay. So now we'll be studying with static routing. Static routing. Why we require static routing? I'll tell you now. Why we require static routing? Tell me now. Because we saw the configuration of routers, right? 3 routers we configured in JNS3. What was the issue that we faced? R2 was not able to. So let us not talk about disadvantage. It is also having some advantage with respect to smaller LANs. Okay. Smaller LANs doesn't require, source to destination. So sorry, from end user device to the router, which was completely isolated from end user device. It was not able to ping back, right? Yes or no? So that was a simple configuration that we saw. Yes, guys, that was a simple configuration that we saw with respect to which one? R1, right? Yes, R1, R2, and R3 was there. Which was the end user device? Which was the end user device, guys? Yeah, R2 was the end user device. R2 was not able to ping to R3, right? Yes, because R2 doesn't know the route information. Yes or no? R2 doesn't know the route information here. So to enable that route information, so we need to apply static routing for smaller LANs. Is that clear? We need to apply static routing for that smaller LANs, and it can be achieved by the network administrator. It can be achieved by the network administrator. Exactly. Once again. Okay. Can you see the figure now? Are you able to view the this architecture? Yes. So how many routers are there here, guys? Yes. Okay. Shall we construct one simple architecture? Shall we construct some simple architecture? Then shall we configure this architecture later after? Yes. Good, na? Yes. Shall we construct? Yes. Okay, fine. We'll construct one simple architecture as of now, and we'll look into that complex. I mean, this architecture is a bit complex for your understanding. We'll construct a simple architecture as of now. Okay, fine. So here R2 from R3, it was not pinging up, right? So let us try to design simple one. Yes, yes. Let us go with the simple one. No issues. I'll configure it. Wait. Anyone here from Mysore? No, I was on mute. No, no one is from Mysore. Okay. Bangalore? Anyone from Bangalore? Okay. Yeah, we are finding so many rains, right? So there are so many glitches with respect to internet connection and everything. From past 3 days to 4 days, we are having heavy rain. Yes. One second. I just rebooted my router. 1 second. I mean modem. Okay. Is my screen is visible, guys? I'm audible to you? Okay. So sorry for the inconvenience. Okay. Fine. Okay. See, I'll show you the syntax. Okay. I'll show you the syntax of configuring a static root. What you need to keep it in mind is, okay, there are two types of configuration. Is that clear, people? While configuring the static root, there are two types of configuration. So one configuration is with respect to interface. Can you see here? Are you able to see here? One configuration is with respect to the hop. The next hop IP address. The next hop IP address. Both holds good. Both are holds good. Both also works and it will define the static root. Is that clear? Both also give the same see the static roots are defined in such a way. The static roots are defined in such a way with respect to the exit interface and the next hop IP. Is that clear? Yeah, I'll tell you how it is happening. I'll tell you. No issues. I'll tell you. Next hop IP and the exit interface. Is this clear? Just be aware of this rule. Just be aware of this rule. I'll just copy this. And I'll add this to the new one. And I'll just add with this the new one. Static network. Okay. So for this, what I do is I'll take 4 routers. I'll take 4 routers. Clear? I'll take 4 routers. Not visible? Okay, is it visible now? Yes. I've taken 4 routers. Fine. So what I'm trying to do here is what I'll try to do here is I'll just try to configure the IP address. So before that, let me take this. Let me take this and we'll keep it here. So this is one part. This is one part. And the other part is OR. So instead of exit interface, next op IP. Is that clear? Next op IP. Instead of exit interface, next op IP. So this is the only difference. Both will work. Okay, both will work. No issues in it. Both will work. Either this or this. Both will work. So now how many routers are there, guys? How many routers are there? 4 routers are there, right? Okay. So what I do is I'll just name this as PC1. I'll just name this as PC1 and I'll just name this as PC2. Is that okay? Yes. I have named this as PC1 and named this as PC2. I'll just drag this here and I'll just keep it here. Fine. So now I'll just connect with the fast Ethernet itself. Anyways, you know how to enable the serial connectivity. I'll not take much on that. Fine. I've connected to the fast Ethernet. Is that clear? Okay. So how many end user devices we have got now? Yeah, let me create the ABC. Fine. How many end user devices we have got? 2 end user devices, exactly. 2 end user devices. So what I do is I'll just take a quick look on 1 second. It's very issue. Always an issue. Okay. So this side of the network, I'll nominate it as completely for classful itself. I'll nominate. Okay. For the complex architecture, we'll look into classless. Don't worry. Fine. For complex architecture, we'll look into classless addressing. For this simple architecture, we'll look into classful. Are you okay with that? Yes. 192.168.2.0 Is that clear, guys? 2.0/24. So this is one. Okay. I'll just take this and I'll just edit this. Edit this for 3.0. That is from R1 to R3. From R1 to R2, it is 3.0. Is it clear? Clear for everyone? Okay. Now, I'll take one more and I'll edit this. For your easy understanding, I have taken the similar class, similar, everything for similar. Okay. For your understanding. So I'll just nominate it as 4. Is this absolute? Is this absolute? 192.168.4.0, 192.168.3.0, 192.168.2.0. Now tell me, PC1 belongs to where? Which network? This network, right? PC1 belongs to this network. Can I configure PC1 for 2.1? Can I configure it as 2.1? Yes. Next, let us come to R1, which is mutual to PC1, right? So now tell me R1's F0 bar 0 interface, F0 bar 0 interface to be configured what? 192.168.2.2 I'll give. Let it be continuous. So it can be 2.3 or whatever you like to do. So it should not exceed more than 255. Till 255 you can assign. No issues. Is that clear? Till 255 you can assign. If it is of 256, it is invalid. It will not take. Okay. I have given 2.2. So again, R1 is configured with which address? With which interface? F0 bar 1, right? F0 bar 1. So it belongs to which interface? 192.168.3.1. 3.1. Fine. Next, let us come to R2. R2 is belonging where? R2 is what? Yes, it is having two interfaces again like R1, F0 bar 0. Then next. So which is the interface? I mean, which is the address that I need to assign for F bar 0? F bar 0, yes, exactly. 192.168.3.1. Sorry, 3.2. Already 1 is taken care here. So I'll give 2 here. Because it is with respect to 3.0 network, right? It is with respect to 3.0 network. Exactly. Yes. Next, I'll take R2. R2 is with what? F0 bar 1. Yes, right? 192.168.4.1. Can I give something like this? 4.1? Okay, fine. Next. How about PC2? How about PC2? It is 192.168. Because only one interface. PCs are configured for only one interface, or end user devices, it is configured for only one interface, 4.2. So you are now got the clarity with respect to how to assign the interfaces IP addresses, right? You now got the clarity. Yes or no? Yes, exactly. Very good, very good, very good. So I think we are good to go further, right? Okay. So let us take the notepad now. Okay. Let us take the notepad and we'll configure our PC1 first. PC1. Clear? PC1. Can we give IP? Yes, you can give. So see, only for your easy purpose, I'm giving this. That's it. So what is PC1, guys? Tell me. So what is the initial configurations I need to take care of now? What is the initial configuration I need to take care? Yes, exactly. Very good. Conf T then. Conf T then. Yes, interface. And which is the interface which it has got? Which is the interface it has got? F0 bar 0. Exactly. So we are in this interface now. Can you see my cursor? Are you able to see my cursor now, guys? We are in this interface now. So now let me enter into that interface. So once we enter into that interface, IP add. IP add. So what is the IP address we have given for PC? Can you see here? What is the IP address we have given to PC? Yes, 192.168.2.1 we have given. So the subnet mask will be, because it is /24 we have given, right? It is /24. /24 belongs to what? Mask ID. It belongs to this mask ID. Yes, someone remind me saying that after conf p, it should be no IP routing because it is an end user device. It's an end user device. So no IP routing should be given. Lay drafted no shut. No shut, and at last you can give end or exit. Anything is fine. End or exit. And after that, provide WR. No issues. Do WR or WR. I mean, if you are providing end, then it is WR. If you're providing exit, then it should be do WR. Exactly. Yes. So now we did this, right? We did this. I'll just copy this and I'll also create the mapping for PC2. Shall we go to PC2 now? Yes. So what is PC2? It is 4.4.2. 2, right? 4.2 with respect to this interface. Yes, what is, yeah, PC2 is what? 4.2. We have assigned it, right? 4.2. Okay, we have taken care of this network. Okay, along with the network IP, we have taken care. Next, let us jump on to which router R1, right? R1. Okay, I'll just delete this one. I'll just delete this one and I'll just add FA0 bar 0. FA0 bar 0 is connected to which network? Tell me that. Last 2 octets, you tell me which network it is connected to. FA0 bar 0. FA0 bar 0. R1's FA. R1. Yeah, to PC1, right? Which network? 2.0 or 3.0? 2.0, exactly. You please mention that, okay? 2.0, right? It is connected to 2.0. Exactly. It is connected to 2.0. Now it is 2.2 because already 2.1 is acquired by PC1. So I'll give 2.2 here. Exactly. Next. So one more interface is there, right? Yes, I'll just delete this and I'll add FA0 bar 1 and I'll add 3. Yes, right? FA0 bar 1 leads to which network? Can you see here? 3.1. Exactly. So it is 3 and we are good to go. We are good to go with the network. Okay. So R1 is also configured, right? R1 is also configured. Is R1 is left out? Do you think R1 is left out, people? No, right? Yes. R1 is not left out. So we are good to go. Yes. Now let us take R2. And I'll just delete this. Let me check R2's FA0 bar 0 interface where it is getting connected with 3.0 network. So it will be 3.2 because 3.1 is already acquired by R1. 3.1 is already acquired by R1. So I'll give the IP address as 3.2 here. Yes. I'll just delete this and okay, fine. And so FA0 bar 1, which is leading to which network? FA0 bar 1. 4.0, exactly 4.0 network. So that 4. So what is R1, R2's other IP address? It is 4.1, exactly. I think everything is configured, right? So all the devices are configured. Yes or no? All the devices are configured. Now what I do is I'll just assign the IP addresses for all the devices as per the configuration what we have done. So let us take PC1 first. PC1, okay, it is not been booted yet. Okay, let it get booted. I'll turn on the device. Let me give some time. Okay. So ample amount of time is given for booting. Fine. I'm not audible to you? Audible. Okay, thank you. So let us go to PC1. Fine. So PC1, we have added the address. Could you see that? For PC1, we added the address. Let me check whether it has converted to end user devices or not. Show IP root. Is it connected or not? Because it is not displaying the routing table, right? It's connected now. Yes. As of now, it is connected. Exactly. Now, let us go to PC2. We'll configure the end user devices first. Fine. Fine. Let me check this as well. Okay. Even it has not been identified with any routing table, so it is converted. Fine. So now let us go with R1. 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 First interface address. So I've given what? FA0 bar 0 and I've given this address. Right? So everything is changed, and also I'll give this mapping as well. Once again, I'll just zoom it. People are asking to zoom it. So in between, if you ask, there will be some delays. Is it visible now? Yes. Okay. Okay. So with respect to FA0 bar 0 interface, I've given. FA0 bar 1 interface also I'll be giving now. I've given now. Okay. Now let me check whether it is configured as it is two interfaces. Show IP interface brief. Can you see? Good to go? Good to go? Okay, fine. Let me check. Show IP route. Show IP route. Okay, directly connected. So two networks are displaying here. 2.0 network and 3.0 network. Did I configure this? Automatically it is taking, right? The directly connected network, it is automatically taking, right? With respect to the interfaces. Yes. Okay, it is displaying its routing table now. This is the routing table. Next, let us check with R2. Let us check with R2. Okay. Fine. Show IP route. Are we good to go? Are we good to go, guys? Done? Yes. Now the thing is, when I ping from PC1, when I ping from PC1 to R1, when I ping from PC1 to R1, that is ping, I'll ping the internal network itself, 192.168.2.2 itself I'll ping. So 2.2 is existing here on this interface. It should become success, right? Okay. Now I'll ping 3.1 I'll ping. It is also taking because this router is associated with this interface, so it is also taking. Shall I ping 3.2? 3.2 belongs to which router? Which router 3.2 belongs to? R2. Am I able to get the message? Once again, guys. People, I'm really sorry. I was getting in between calls. Sorry for that. Please excuse me. Am I audible to you all now? No. I was getting some call. I was in the call. These were the important calls, right? We need to do multiple tasking. So please forgive. So in between calls will be, I am the track anchor. So many number of issues will be there. Please try to understand. Hope you people will understand. Okay. No. When it is really important, I'll take the calls. Okay. Of course, out of 10 calls, 6 calls will be important on my phone. Yes. Okay, Sanjay, it is your wish. Interface, okay. Yes, it's completely my wish. No issues. So whatever the configurations we do with, it is completely my on our wish. We can configure it. No issues on it. Okay, but in exam, whichever the interfaces they give, right? So accordingly, you need to configure. I'll tell you how to do it. Okay, I'll tell you how to do it. Yes, exactly. I think this part is accountable for you, right? From PC1, I'm able to ping both the interfaces of R1 from PC1 because it is directly connected, right? Because it is directly connected and it is giving the communication. But for R2, the address, I'm not able to communicate. See? So here comes the picture of static routing. 3.2, it is getting failed. Exactly. See this network, it is getting failed. Exactly. So now I should be able to configure for static routing. So let me go back to the syntax. Shall we go back to the syntax of static routing? Yes. Yes, we'll go to the syntax of static routing now. Now tell me, this particular thing need to be configured for R1 and R2, not to the end user devices. Please keep it in mind. These syntax, whatever the syntax it is given here, either this or this, it has to be configured only on the router devices, not on the end user devices, guys. Are you getting cleared? Are you getting cleared? Yes, we need to configure on the router devices, not with the end user devices. Yes. So so many of them will think that okay, fine, we need might be we have to configure with that device as well. Now let us go with R1 now. I'll take R1. So I'll just zoom in. 1 second, I'll just change the settings. Okay, apply. Clear, guys? Is it visible? Yes. Okay. So what is this? Before R1 is in the privilege mode. So I need to enter into configuration mode. Is that clear? Whether I am in the configuration mode now? Yes, I am in the configuration mode. Now, you need to think of how many networks R1 is connected with. 2 networks, right? 2 networks. Now, for example, which is the source and which is the destination here, guys? Which is the source and which is the destination? PC1 is the source and PC2 is the destination. Even for R1 also destination will be PC2, right? So I'll mark it. So this is the source and this is the destination. I'll mark it. Okay. So this is the source and this is the destination. Got it? Clear? Yes. Now where we are? We are in R1. So for PC1 and for R1, PC2 is the destination. Clear? For PC1 and R1, PC2 is the destination. Clear? Okay. Now tell me, what will be the destination network address? So can you see here what we have given? IP route. Leave IP route. Leave IP route. Destination network address. What is the destination network address? What is the destination network address? Yes, exactly. Destination network address is 4.0. Exactly. For R1, I'm trying to configure with destination network address. Once again, IP root. So this is the command IP root. The syntax I'm following with 192.168.4.0. Is that clear, guys? Is the concept is clear? Yes. What is the subnet mask? What is the subnet mask? 24. So I'll give something like this, right? 0. Yes? Clear with the concept? Okay. So which is the left out one? Either you can provide exit interface or you can provide the next hop IP. So people will get confused here. So to avoid that confusion, always whenever you configure the interfaces, right? Whenever you configure the interfaces, so please take care of that mapping in such a way. So what is FA0/0 we have mapped with? What is FA0/0 we have mapped with, guys? R2's FA0/0, what we have mapped with? R2. 3.2, right? Yes or no? That is 192.168.3.2. For R1, which is the destination? PC2 is the destination, not R2. No, not R2. Please don't confuse here. It is not R2. PC2 is the destination. Exactly. PC2 is the destination. I'm not talking about destination network, people. I'm talking about destination. It is PC2. Repeatedly, I'm stressing it out. Okay. Now, R1 has got two probabilities to reach the destination now. Two probabilities. That is either through the IP address of this interface or the exit interface. Which is the exit interface to reach PC2? FA0/1. FA0/1 is the exit interface. So this will be the incoming interface, right? This is incoming interface. This is incoming interface. Where is destination is residing with? Destination is residing at R2's end. It is residing in R2 end. So the exit interface can be this, or next hop IP can be this. So now what I'll provide is I'll provide the next hop IP. Always make a practice of providing only the next hop IP because it will not create any confusions. Clear? Is the concept is clear? Yes. Now it has been added. So now you can press end and save the configuration. Press end and save the configuration. Is that clear? No shut. No, already it is up. We are adding only the roots. That's it. We are adding a static root. That's it. So there is no funda of adding the no shut command again. Is this concept is clear to everyone? Either you can give FA0/1. Is that clear for everyone? Either you can give FA0/1 or the next hop IP of this R1. So which is the next hop for R1? R2, right? Exit or end is anything is fine. Exit or end, anything is fine. Which is the next hop? Which is the next hop router for R1? It is R2, right? It is R2. Now, while reaching to the destination, it has to reach via R2 itself, right? R2 is via. Yes or no? R2 is via. Now, it has got two probabilities. Either it can go with next hop IP, immediate hop IP, or it can go with next exit interface. Which is the next exit interface? Whether it is 0/0 or 0/1. It should be 0/1, exactly. It should be 0/1. So I've given the next hop IP instead of exit interface. You can also give exit interface. So we'll check for R2 when we configure R2 configuration. When we do the static mapping, we'll check into it. Okay. Now let us go to R2. Till now we did R1. Now let us go to R2. So now tell me conft IP root. So which is the destination network for R2 now? Which is the destination network for R2? Yes, PC1. So where is PC1 is residing? 2.0, exactly. 192.168.2.0, exactly. It is 2.0 network. Next, the subnet mask will be same. Clear, guys? the subnet mask will be the same. Now here I can give exit interface. I'll give exit interface now. I'll give exit interface. You can give the next hop IP. Which will be the next hop IP? Which will be the next hop IP? 3.1 will be the next hop IP. 3.1. 3.1 will be the next hop IP. I'm giving F0 bar 0. Let me complete this. I'll repeat it. Wait, let me complete this. See, for R2 I'm designing now. The route I'm designing is with respect to R2. R1 I gave the knowledge of the route now. R1 I gave the knowledge of the route. For R2 I'm giving the knowledge of the route. So now here I'm not taking the exit interface. Instead of exit interface, I'm taking the exit interface instead of hop IP. Yes, exactly. So it holds good. Then I'll give end. Next, WR. Is that clear? Now what you need to do, just go to R1 back. Just go to R1 back and give show IP route. So the routing table should display the static route. Can you see the static route here? Can you see the static route? Yes or no? So earlier only these two things were displaying, right? Only these two were displaying. Now it is displaying with this one, so that via 192.168.3.2 interface IP, it can reach 192.168.4.0. Yeah, I'll ping it. Wait. I'll just check the routes whether it is configured or not. Show IP route. It's directly connected. Is it directly connected? Yes, because the interface are mutual for R1. So it is showing with 2.0. Let me check. If there is any error, let me check. Okay, now what we do is I'll just ping from PC1. So what is the PC2's IP address? 4.2. From PC1, ping 192.168.4.2. It should ping. One second, let me check. Okay, is it pinging now? No, 60%. There will be a delay. Minimum delay it will be there. If you re-enter again, it will reach with 100%. Can you see here? 100%. So if I ping it again, okay, fine. I'll ping it again. Can you see? 100%. Initially, there will be some minimal delay. Yes, Chetan, please go ahead. Chetan, yes, Chetan. Chetan raised your hand. What is the issue? Chetan, you can unmute yourself.
It for both the routers. Na?
One second, Chetan. One second. Yes, please, Chetan.
Sir, it is necessary to do R2 to PC1 and R1 to PC2. Means both
yes,
are required.
Of course, right. Because see, I'll tell you this. Why we created that relation? Because see, R2 is mutual to whom? R1 and PC2,
R1.
Right?
Yes, R1 and PC2.
R1 and PC2. It is a directly connected network for R2, yes. Right? So when I want to create the associate with PC1, of course it need to take the accountancy of R1, and again it has to take the accountancy of PC1 as a destination, right?
Right, sir.
Exactly, no?
Yes.
Yes.
That's the reason. Okay, sir. Thank you.
Yes, that is the issue. Okay.
Yes.
But sir, in second case, R1 was showing directly connected to PC2. Why?
R1 was because R1 is already associated with this interface, na? R1 is directly associated with this interface, na? 2.0 interface is already associated with R1, na?
Got it, sir. Got it.
Yes, got it.
Yes. Thank you.
Yes, yes. So let me check with PC2 as well. Are we able to ping PC1 from destination? 192.168.2.1. Am I getting the reply? Yes. See, the success rate is 100%. Got the concept? Do you want me to repeat? Do you want me to repeat the concept?
That means, sir, we have to only do static one time, na? That will connect.
Yeah, that
both
will
the
connect.
index.
That will connect. Yes,
Yeah.
exactly.
Okay.
That will connect. But you need to present appropriate destination network. Which is the destination network? It is to be present.
Yes.
Okay, but step by step, I'll tell you now. Step by step, I'll tell you. Okay, I'll repeat it once again. Let us take 10 more minutes for this repetition. Step by step, I'll explain.
Can you show me the diagram?
Which one?
Show me the notes, please.
This one.
Notes, please. Close it. Okay, yes. Now R2 has two hop IDs, F0/0 and F0/0.
No. It can't be said as hop. See. That is
Next one.
what. See, hop is R1. For R2, hop is R1.
Okay.
Okay, for R1, R2 is the hop.
Okay.
You can't take the interface as a hop. Its own interface will not act as a hop. Is that clear?
Okay.
The router's interface itself, it will not act as a hop. That router's immediate router will act as a hop. Is that clear for you?
Yes, sir.
Yes. Okay, I'll just explain. I'll just explain it again. Okay. For so many confusions are there for so many folks. I'll just explain it. Yes. Yes, I'll explain. Give me a moment. Okay. Now, people, tell me how many devices are there together altogether. How many devices are there? 4 devices. Huh? There are 4 devices exactly. So out of 4 devices, what we thought was, let us configure 2 devices for end user devices. Yes, right? Yes or no? Yes. So we set it as PC1 and we set it as PC2. Right? So it is something like your laptop or your desktop, whatever it is. Something like. Okay. You can feel that it is your laptop or desktop on in a office area. In an office area. So this is completely one single LAN. For intra-LAN activity, we have configured this. Okay. This is completely an intra-LAN. You can situate something like that. Okay. Is that clear? Yes. Now, out of this, to make this PC1 as which was a router before, so what was the step that we took? What was we took? Just tell me, what was the step? Steps for static routing. Okay, steps for static routing. The first step. Tell me the first step. No. First, tell me the first step. To make router as end user device. So which is the main thing that we need to add? To make router as end user device in global mode, in global mode after conf t command execute no IP routing, right? So this will make what? Convert router to end user device. So this step, it will convert router to end user device. Next, assign IP address to all the devices. So you know how to assign the IP addresses, right? All the devices with respect to appropriate network address on their interfaces. The second step is clear to everyone? On their interfaces. Is it clear? Yes? Is the second step is clear? Okay. Next. While the third step, only directly connected networks will be able to communicate with each other. So this is third step. Yes or no? From PC1 to R1 it is directly connected. From R1 to R2 it is directly connected. PC2 to R2 it is directly connected. So they are able to directly communicate, right? Need for static routing comes into picture only when there is no direct connection available. Did you got it? When there is no direct connection available. Is this point is holds good? Is this point is holds good to everyone? Yes. The fourth point is holds good? Yes. So need for static routing comes into picture only when there is direct connection available. My voice is breaking. How about now? How about now? Fine. Okay. Now, step number 5. While configuring the static route, it can be configured only on routers. Is this point is good? Is this point is good or not? Fine. While configuring the static route, it can be configured. Yes, it can be configured only on routers. Right? It can be configured on the routers. Sixth step. Router destination network with subnet mask routers destination network with subnet mask and immediate next routers interface hop IP to be taken care. to be taken care. Is that holds good? Is this point holds good? Is this point holds good for everyone? Guys, are you there? Yes. Next immediate immediate next routers interface hop IP to be taken care. Yes or no? See, in this scenario, this router has got two interfaces. This router has got two interfaces. R1 is looking for destination. So when it is looking for two interfaces, so which is the hop IP that it has to take? This interface configured hop IP, right? There are two IP addresses for this router now. There are two IP addresses on this router. Whether it should take 4.1 or whether it should take 3.2. Whether it should take 3.2 or whether it should take 4.1. Tell me. It has to take 3.2. If it is going only with interface, then it has to take FA0/1 exit interface. Is that clear?
Hello, sir.
Yes.
Sir, without making the static connection, if you want to...
Brother, please let me know who is this?
Chetan.
Chetan, please tell me, Chetan.
Sir, without making the static connections, if you want to pass a message to PC1 to PC2, then it won't pass, na?
There is one more way. I'll approach that. Okay. I'll approach that. And this is the feasible way. Okay.
Here we have to, firstly, we have to establish the connection between PC1 to R2 and PC2 to R1, right? No?
Now, please repeat it. What is that?
We have to make, we have to establish the connections between PC1 and R2 and R1 to PC2 for
R1 to PC2. Exactly. See, first of all, you should think about... Yes.
But
yes,
sir, without making the static connections, via R1, it is not possible to go directly.
How it is possible? From R1, it can reach PC1. But when PC2 is looking for PC1's connection, it has to reach via R1 itself. Are you getting clear?
Yes,
while PC1 is looking for PC2, it has to reach via R2. Are you clear?
Yes.
Did you got the point?
Yes, sir.
Okay. When PC2 is looking for PC1, it has to reach via R1 itself.
R1, yes, sir. That's why we are establishing the connections.
Yes, that is why. Because, see, R1 knows what is R2. But how come PC1 will be knowing R2 is connected to R1?
Yes.
We need to give that knowledge to R1, right?
Yes, R1. Yes.
We are not giving the knowledge to PC1. We are giving the knowledge to R1. So R1 is convincing PC1, okay, fine, I got the route to reach PC2.
Yes. Fine, sir. Got it now.
Got it?
Yes.
See, because, see guys, for example, from today onwards, you people know me, right? From today onwards, you know me. Oh, there is an educator called Sanjay in Mysore DC who will educate networks. Yes or no? So this is the information you got about me. Fine. If you're going and telling, for example, if you're going and telling your parents saying that, do you know Sanjay? Are they aware of me? Tell me, are they aware of me? No, right? So only when you tell them, when you tell them, okay, fine, there is an educator called Sanjay who taught us today, then only they will be coming to know, right? So even R1 and R2 is also facing the same issue here. So when PC1 want to reach PC2, PC1 should be aware of the appropriate route selection. So that who is giving that knowledge to PC1? R1 will say that, okay, fine, no, don't worry, guy. I'll tell you the route. So I got the information about R2. He has given me the route to reach PC2. Now tell me, if from R1, can I ping PC2? No, right? Immediately I can't ping because only R2 knows who is connected to him. Yes or no? Only R2 knows who is connected to him. Now R2 is giving what? The knowledge to R1. Don't worry, man. I'll give you the complete route for PC2. I got his entry on my network. If it is not there, he will immediately discharge the packet, right? discard the packet. That is what packet filtering is all about. Got the point? Is the point is clear? Everyone? Yes. So I know there is a challenge while understanding this next hop IP and this one. So let us go with Sanjay. Write the commands parallel in a notepad that we can compare what commands we are using in all the devices. Okay, no issues, brother. No issues. Okay. Can you see the notepad? What is that message? What is that message? So we are making router intelligent. Yes, that is what. See, in the first iteration, in our first demo, what we saw, guys? What we saw? Only there were 3 routers. Only there were 3 routers. So after that, we came to know, okay, fine. Now, when the routers are isolated, only the mutual router is able to communicate for us to the entire park, right? Yes, he is the one who will be representing the entire route. So now what we are trying to do, we are trying that router as an intelligent one. So he should be knowing, okay, fine, I know this, I know this. It is something like a junction. You are seeing the train junctions, right? You are seeing the train junctions. Yes or no? So based on the train junctions, you will be able to hop from one city to the other city. Right? So likewise, the router will also try to communicate between their immediate hops, saying that, okay, fine, you are the immediate guy, right? Okay, fine, I'll just give you the hop back. And I'll just tell you what is the exact way to reach the destination. Yes or no? Yes. Explain. Okay, Golangi. Okay, fine. I'll explain. Don't worry. Okay, I'll explain. Yes. See, next hop IP is nothing but for R1, who is the next hop? Tell me. Tell me now, for R1, who is the next hop? Hop. I'm talking about hop, not interface. I'm not talking about interface. I'm talking about hop. Who is the hop? R2 is the hop, right? For R1, R2 is the hop. Please understand that knowledge. For R1, R2 is the hop, right? For R1, R2 is the hop. Now, what we are telling here, next hop IP, you can consider next hop IP or exit interface. Exit interface. So what is next hop? R2, right? What will be the exit interface of R2? What will be the exit interface of R2? FA0 bar 1 leading to destination. Please remind, leading to destination. Always keep it in mind, leading to destination will be the exit interface. Is that clear? Okay, let me create one confusion for you now. Let me create some confusion for you. Okay. Okay, one second. Now tell me, think that R2 is also connected to PC3. Okay, guys, think that R2 is also connected to PC3. Okay, one second. I'll just restart. For the connectivity issues, I'll just restart this. Okay, fine. I'll add one more slot for this. Okay. I'll take this and I'll add one more slot. Fine. I'll just start this. Okay. No, don't get confused. Don't get confused. For make you understand better, I'm doing this. So PC3 is there, right? PC3 is there. So how many end user devices are there as of now in the architecture? 3 end user devices. Yes. Now tell me, for R1 you said that R2 is the hop, right? So now tell me which is the destination. For example, R1 is looking for PC3. So which will be the exit interface? F1 bar 0, exactly. But what will be the next hop IP? Which will be the next hop IP? Which will be the next hop IP? Next hop IP 3.2. It remains the same. See, it remains the same. Is that clear? Next hop IP remains the same, but only with respect to exit interface you are looking for the destination, it is getting changed. So if R1 is looking for PC2, which is the exit interface? Which is the exit interface? Exactly. 0 bar 1 is the exit interface. Got the concept clear? Got the concept clear? Yes. For static case, extra one router. No. Extra one router, I gave it to for your convenience. You can add multiple routers here. You can add multiple routers according to your convenience. You can make this network complex. Okay. Please give us time now to do this all. I'll give the time. Don't worry. I'll give the time. So you can take a small break now. You can take a small break here till 4:20, and you can resume back at 4:20. 4:20 will attain with the complex network, which is there in your legs. Is that okay? And you'll get the clear idea of static routing. Okay. Okay. I'll make sure you'll get excel in it. Don't worry. Don't worry. Fine. Okay, let me stop sharing here and please go for a break, have some refreshment and come. Break till 4:20. Break till 4:20. Please resume back at 4:20. Chakravarti, please go on mute. Chakravarti, please go on mute. Yes, everyone are back here. Okay. Yes, welcome back, guys. Good evening again. So I think you are good to configure with static routing, right? Yes, are you good to configure with static routing as of now? Yes. Only few are replying. I don't know. How about the project folks? Project folks, I think due to VDI issues with you guys, so I feel very sorry for that. Need practice, of course. You need practice. Yeah, until you practice, you won't be perfect on it. But the concepts you are getting, yes, absolutely fine. Okay. So now what we'll do is we'll just go with the Lex component of this content. Yes. Don't you feel this topology is very huge? Is this topology is very huge or not? Yes. The topology is very huge. You find it very huge, right? This topology is very huge. But according to me, there is nothing. There is nothing. There we added one device as a host device, end user device. It is here, they are adding only two devices. Don't feel that, okay? There are less number of, the routers are not directly connected. In this scenario, the routers are not directly connected. Yes or no? Yes or no, guys? The routers are not directly connected. I'll explain the scenario and we'll take some other topology for our work. Okay, I'll take some other topology for our work. Is that good to go? I'll explain this topology and explain. Okay, now tell me. There are three different LANs. Do you agree? Do you agree with this? Of course, right? There are three different LANs. Yes. So LAN 1, LAN 2 and LAN 3. Once again. Switches you are not supposed to configure. Okay, switches you are not supposed to configure. Don't worry about the switches. I'll just check with this exercise how it can be done. Okay. Okay, where is that? Okay, yeah. Switches, don't worry about switches. So that is why I told you, don't worry about the switches. Whichever the configurations that will come for your hands-on part, like that type of configurations, we'll do it and we'll solve it. No issues. Okay, fine. So LAN 1, LAN 2 and LAN 3 are there, right? So don't worry about switch. Switch are only the devices which are connected intra. So don't worry about that. For internet activity, for inter-networking activity, we are connected with the routers. So now tell me how many networks are there? How many different networks are there, guys? Tell me, how many different networks are there? 3 different networks? Yes. So we got 3 different networks, right? Yes. One is associated with 10 dot series, one is associated with 172 dot series, and the other one is associated with 192 series. Okay, I think it's not popping up. Need the device. Fine. So one is 10 and the other one is 172 series and the other one is 192 series. So this is classless, and this is classful. Do you agree? Classless, and classful. This is classful, and this is classless, and this is classless. Yes or no? So there are mixture of heterogeneity that exists, right? So the network structure is not homogeneous. Do you understand? The same way you will be experiencing in your hands-on as well. So, but don't worry about that. Order. Now, for configuration of this network, so what will you consider? What will you consider while configuring this network? So, which is this R1, right? This is R1. Yes or no? This is R1. So for configuring R1, so what is the commands that, please tell me now, for configuring R1? So till now what we have seen is, we have seen with classful addressing. Now let us also check with classless addressing. Yes. Yes. Next one is interface F0 bar 0, then IP address 10.0.0.100 255.255.255.0. So this is completely classless, right? No shit. Yes. Okay. Now tell me for R1, which is the next hop? For R1, which is the next hop? Which is the next hop? R2 is the next hop, exactly. R2 is the next hop. Now, for R1, which is the next hop IP? For R1, which is the next hop IP? Which is the next hop IP? Next hop IP. Which is the next hop IP? No, I'm talking about IP address. Which is the next hop IP? It should be 172.16.0.2, right? Yes. Next hop IP. And or which is the interface? Which is the exit interface? Or it should be F0 bar 1. Yes, right? Or it should be F0 bar 1. Which is the F0 bar 1 exit interface I'm taking? For example, I need to check with the destination. If it is host 4, people please listen to here. If it is host 4, if R1 is looking for host 4, which is the exit interface? Tell me. It should be F0 bar 0. Yes, it should be F0 bar 0. If it is looking for host 5 or host 6, if R1 is looking for host 5 or host 6, which will be the interface? F0 bar 1 will be the interface. That's it. Very simple, na? Very simple. That's it. For host 4, why it will go through what is RE? Why through it will go? See, for host 4, where it is connected for host 4? For host 4, where it is connected? Tell me. Host 4 is connected to which network? This one, right? Host 4 is connected to which network? 172 network. And also host 3 is also connected to 172 network. But here, which is the other next hop IP, or which is the next exit interface which you want to connect? So it should be the router's hop IP or router's exit interface, right? Yes or no? It should be the router's hop IP or router's exit interface. If there is no R2, then it will go from it is directly connected network. There is no need of static route at all. If it is not connected to R2, then there is no need of static route at all, because everything is connected to R1. Very simple. Yes. So if there is no R2, everything is connected to R1, right? See, everything is connected to R1. You want me to configure this network? You want to configure this network? No. I'm asking you whether I want to configure the same network. Okay, let me configure. No issues. complex static. Okay. Now tell me. So R1 and R2. So there are two routers, right? There are two routers. Taken two routers. Fine. So there are two routers. So I think I need to add. I'm not adding switches here. Instead of switches, I'll directly connect it to R2. So no issues. Okay. I'll directly connect it to R2. So I'll take how many end user devices were there? 1, 2, 3, 4, 5, 6. Okay, I'll take 6 end user devices. Fine. Fine. Okay. Shall I reduce one device because I need to add more interfaces? It will get confused still again. Shall I add only 3 end user devices? Okay, is that okay? Fine. Okay, guys, I'll just delete 3 devices then. Or else let us take switch. For your understanding, for the same configuration, let us take the switch. No issues. But don't try with switch. For your hands-on, switch will not be there. Okay, don't try with switch. I'll just give you. I mean, switch is the forwarding content. That's it. It will just forward. No, because people will appeal. No, it was not done. That's something. I mean, whatever is there in Lex. People will appeal later on. It was not taught or something. So you understand the situation. Okay. Or else, okay, fine. What to do? Shall I take switch or not? Shall I take switch or not? Okay, no switches. Okay. So if you are telling take it, okay. Let us not disappoint them. Okay. So this is Ethernet switch 1, switch 2, and switch 3. Fine. So all these are end user devices. All these parts are end user devices. Is that okay? So what is there to laugh, Dishu? Stop laughing. Okay. Now connect. 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 Is the same configuration what we have got there? Yes, is the same configuration? Okay. Fine. No issues. No issues. No. So please be aware of that. Switches will not be there. I'm repeating it. Switches will not be there for your hands-on. Only for your understanding, switch will not do any other task. It will just forward. That's it. Whatever the criterion that is given in your task, you have to understand accordingly. Okay. So let us configure from R1. So R1 is what? 10.0.0.0 network, which is /24. Right? Fine. So this is what? 172.116.0.1 network with /24. So this network so it will create some confusions for you. So I'll just change this address. Okay, I'll just take 200.10.0. 192.168.0/24. One 192.168.1.0/24. I have not taken the exact. What is the answer, please? I'm doing the task here, right? How come I'll be able to look into your. If you want to talk, you can talk. Unmute yourself and talk. Random IPs, yes. I've taken the network address here. Okay, I've taken the network address here also. I'll change. See, people will go wrong. If I'm not locating it properly, people will go wrong. So this is one network and this is one network. Okay. Is that clear? So all the interfaces are here. Now you have to tell me how to configure this. Tell me now how to configure R3. Let's boot the devices. Let's wait for a while. Okay, all these are end user devices. So I'll just go with one clean picture. I'll just go with one clean picture. So let us configure. I'll just take PC1 with conf t interface f0/0. And what should be the IP? Tell me the IP address. I think it is no IP routing. Yes or no? No IP routing. Yeah, interface FA0/0. Yes, then what should be the IP address? IP add. So what is the IP address? Yes, it should be 10.0.0.1. Exactly. 10.0.0.1. Fine. So I'll just give no shut end and WR. Okay. I'll just configure all the PCs now as per the thought what we are going to go with. Okay. So it is connected to FA0/011. So it will be what? Tell me. Tell me. Oh yeah, subnet. Very good. Subnet is forgotten. Exactly. Thanks for reminding. Okay. So if you are able to identify that, I think some things are going in mind. Okay. Next, PC3. PC3, right? So what is PC3 is all about? So R5 is PC3. I'll change that. Don't worry. R5 is PC3. I'll change that. Yes. What is PC3 now? 0/0. Which network it is connected to? Either this network or this network. Okay. Any network. Fine. 172.16.0.1 I'll give. Okay. 1 I'll give. Next. For R6, I mean PC. This one R2. Now tell me R2. Now tell me R2. Sorry, R6. Sorry, PC4. PC4. So which is the network shall I connect for PC4? 200.10.0.1. Okay, thank you. Next for PC5. PC5, tell me now. For PC5, which is the network? For PC5. 192.168.1.1, right? For PC5, 192.168.1.1 I'll give. And for PC6, yeah. For PC6, it will be 192.168.1.2. Exactly. So let us configure everything. Let us configure with the IP address with respect to all the end user devices. Okay. So let me check show IP route. Okay, it's configured and I think everything will work. So PC, fine. PC, okay. It is also built. So it is also been finished. Next. PC3, I'm going to PC3. PC3 is nothing but R5. Okay. So R5 is also configured. Next, we shall go to R6. R6 is nothing but till where you are given, how much has left out? 5. Okay. PC5. PC5. So R6 is also configured now. So we'll go to R7. Okay, R7 is also configured. And R6, which is R8. Okay. Fine. So I'll just name it. Okay. Not to create confusion for you. I'll just name it PC1. Yes, Chetan, please tell me. PC2. No, you need not to configure the switch. PC3. PC4. Switches can't be configured. Clear? PC5. Next is PC6. Okay. So just to avoid the confusions, we have created that. Okay, what do you want to talk? You can speak. I mean, I'll just option unmute all. Yes, you can speak.
Hello, sir.
Yes.
Yeah. Audible,
Sir,
sir?
if sir, Chetan is here.
Who
Okay,
is
okay, go
Dishu or Chetan? Dishu, please mute yourself.
Sir, if you want to do this thing without switches, then here are 6 end user devices, right? So we can connect. Suppose we can connect 3 PC1, PC2, PC3 to R1, and PC4, 5, 6 to R2, and directly we can connect R1 and R2. So it is possible.
Exactly. See, guys, for your confirmation, I have given the complex topology. Okay.
Yes,
As I
yes.
told you earlier. So at the beginning of the demo, I took a simple topology, right?
Yes.
Now I have taken a complex topology. But for your exam, no more than 5 routers will be there. Okay, don't worry at all. Is that clear for everyone?
Yes, and sir, if we connect, suppose without switches, we connect PC1, only we connect this, means we divide three PCs to single particular router. Then at
Yes.
that time, if you want to do static connection, then only 2 times we have to do, na? Means R2
Yes,
to
only two
R1 and
times.
R1.
Exactly.
Means PC1, 2, 3 are connected to R1. And the rest
Exactly.
of the others connected to R2. Then
Yes,
we
yes.
directly
I got your point, because R1 will be enabled with only one interface, left out with only one interface, and you will be able to connect to only one device. Okay.
Sir, because while doing static things, we means in input we are just giving destination, then subnet mask, and either we give exit interface or a hope IP, right?
Yes,
So
exactly.
these things are common for PC1, 2, 3 as they are connected to single router.
Yes. I'll configure this and let us discuss later. Okay.
Yes.
If it's not hopping with, we'll discuss later after. No issues.
So one more doubt is, can I ask it?
Yes, Dishu, please.
Yeah, sir. Can you
Yes,
just
please
remove that
go
pop-up
ahead.
R1?
Whatever the doubt. Yes, please.
Can you just remove, sir, for some instance, this R1 pop-up? I need to see
Yes.
the GNS3. Yes.
Okay.
So here PC4, we have connect PC4 directly with R2
Yes.
and PC3 with R1. So if you want to access PC4 through R1, so we need to hop through R2, na?
Yes,
Because
exactly.
we have not
Exactly.
connected
Because
that.
PC4 is residing in 200 network.
Yes, sir. But we can directly connect PC4
You can do
to
that. You
R1
can do
also,
that.
na?
You can do that. Just to make you very complex with the topology, I gave 200 for this as well.
So
You
we
can
can
give
connect a
172
single.
network for both the PCs. No issues.
Yeah.
As
So
we
is
did
it-
for as we did for this network, right? As we
Yes.
did for this network, the same thing can be done here as well and here as well.
So one PC can be connected to two routers. Is it okay, sir?
One PC can't be connected to routers. How come your laptop can connect to two networks at a time?
No, it should either connect, sir, only
Okay.
one. Either
Yeah, it is something like, right? So the PC is end user devices is nothing but think that it is your laptop. This device is your laptop. Can your laptop will be able to connect two networks at a time?
Okay. No, sir.
It cannot be connected, na? It can be
Yes, sir.
configured for only one network at a time.
Yeah.
Yes.
Sir,
Got it.
hello, sir.
Thank you.
Yes.
As there is router 2 is there, that's why we connect that PC4 to 200 IP, means the IP starting from 200. If we connect that to 172, then the connection will not be established, no?
No. See here. See. Don't mistake here with the configuration. See, PC3 is connected to which network?
172.
172 network, right?
Right.
PC4 is connected to which network? 200 network, right? If R1 is likely to reach PC4, for example,
Yes.
okay, if it is likely to reach the PC4, you have to establish static route for PC4.
Yes.
Okay, you have to establish static route through exit interface F0 bar 0.
Yes.
Is that clear for you?
Yes, sir.
Yes. So even though R1 is connected to a similar switch, PC4 will not be reachable for R1. Is that
Yes,
clear?
sir. That 200 IP confuses.
Yeah. For confusion itself, I gave that IP.
Yes, sir.
See, if I am giving the plain IP, you will not be able to understand the topology at all.
Yes.
This topology is too confusion because, see, that is why I told you whether you require switch or not. So many appeal that you need switches. Okay, fine, no issues with this. Okay, no issues with this. See, this area is connected to which network? Tell me. It's connected to, right? Yes or no? Yes, it is connected to 10.0.0. network. Next. Okay. So your confusion with here is with respect to this one, right?
Yes, sir. Yes.
This network, right? So this network, it is 172 and this network is
200.
200. Exactly. So if you want to reach from R1 to PC4, it has to go with static routing. If it want to get connected with 172, there is no requirement of static routing. Is that clear for you?
Yes.
Yes. And for this network, we have got the common network address. Is this clear? So for this network, 192.168.1.0. Clear? Clear with the configuration?
Sanjay,
Yes. Who is this?
instead of 200, if we take 172, then no need of static
No,
routing,
no
right?
need of static routing. Exactly. If I'm taking
reach
172,
PC4.
yes, what?
To reach PC4.
Yeah, to reach PC4, instead of 200, if I'm taking 172, so there is no need of static routing at all because it is directly connected to that interface network, right? So this gateway of this router will be common to all the end user devices. This gateway will be common, so it is directly connected. You can check it out. You can check it out. You configure both the configuration and check out whether PC4 is reachable or not. Clear?
Okay.
So only to create the confusion, I have given this two split ups. That's it. Is that clear? Any doubt till? Okay. Are you able to configure this network now? Okay. Any confusions? No, right? Yes. R1, let me go with R2. Do you want me to zoom R1? Okay, 1 second. Once again, change the settings. So multiple times it will ask for zoom in. So that is our trouble. Okay, R1. So what are the initiations that I need to take here? Conf T, then tell me. Interface. So how many interfaces are there? F0 bar 0 is there and F0 bar 1 is there. 0 bar 0 is leading to which network? So IP add 10.0.0.3L add. So next 255.255.255.0. Clear? No shut, exit. No shut. Next, press end and save the configuration. Clear? So administratively it is up. Now one more interface is there, right? For R1. So which is that interface? One more interface. Tell me one more interface. Which is that interface? Yes, 0 bar 1. F0 bar 1 is the next So interface F0 bar 1. Next, IP add 172.16.0. So I'll add something like this to 255.255.0. So no shut, exit. No shut, exit. So do WR. So R1 is completely configured now, right? R1 is completely configured. So let us, where is that? R1 is completely configured. So are we good to go with R2? R2? Yes. So R2 conf T. So how many networks? Interface F0 bar 0, IP address IP address. So which is the leading interface for that? Okay, 200, right? 200.10.0.2. I'll take 255.255.255.0. No shut, exit, do WR. Okay. So which is the next interface? Interface F0 bar 1, which is added with IP address 192.168.1.3L add 255. See, if you're not giving the command properly, it will throw an error. Exit to WR. Okay. So everything is up and running, right? Everything is up and running. Yes. So let me check the communication of PC4. The communication of PC4 from R1. Shall we check it? Yes. Communication of, because we got the funda there, right? Because we are checking out whether it is working or not. Yes or no? Yes. Let me check it. So now Just come out of the console, WR, let me save the configuration first. Okay. So ping, what is the network? Can you please tell me the address what we gave? 0 dot. Static not established. So that is why if it is pinging there, we have to establish the static if it is not pinging. So what is the address? I mean PC4, whether it is PC4, 200.1. People, you are confusing me. So it is not establishing, right? Is it establishing? For this address, whether it is establishing the connection? Yeah. So let me check the same on the same network. We have configured one more, right? So shall we check it for PC3? Because see, the gateway is same, right? The gateway address of that interface is same. Yes or no? See, it is giving it is same network. So that is why it is pinging. Even though they are neighbors on the same network, it is not trying to communicate with this PC4. For that, we need to create the static route. Shall I create the static route for this network? Shall we create static route? Okay, 1 second. On R1, right? R1, I need to create the static route. So what is the idea of static route? Conf t IP route destination network. What is the destination network? 200.10.0.0. Yes, right? Next, subnet mask 0. Oh, sorry, incomplete command. So we need to give the exit interface or IP 0. I'll give the exit interface, or okay, fine, you want the IP address 200.10.0.2. I think so. Yes, right? So exit to WR. Now, okay, fine. So it is building the configuration now. Let me close this and restart the R1 again. Go back to R1. So ping. It's not taking. It's taking some time. Let me check. So which is the IP address I gave there for R1?
Sir, for exit there should be F0/1 na? For
which
R1
one? For which exit?
exit interface. Means 192.16.0.1.
I need to take the hop IP na. Let me configure. Okay, fine. Based on your what I have to have done. Okay. So you are talking about this interface. And see, it is a self interface of R1. So it is the self interface of R1. Let us not take that self interface of R1. Let us take the exit interface of R2's F0/0. So that is what we took, or what? Yes, we have taken this. 1 second. I'll just check what are the IP addresses which are configured on R1, R2. IP interface brief. Okay, 10.0.2 exactly. Fine. It's not giving. 1 second. Let me configure the route for R1, R2 as well. Conf t IP route. So what is the destination network? It is 172.16. What is this? 0.0 255.0 and the exit interface is F0 bar 1. Reading, okay. Exit WR. Okay, let me try to ping 200.10.0.1. Is it pinging? Is it pinging here? Yes, na? It's pinging. R2 and okay. Let us ping it from here. It should ping from here. So that is the challenge. Chetan, did you said that we are not configured this one, right? Interface.
Yeah.
What was your question?
Sir, I don't get that next exit hop exit interface.
Okay, which is the exit interface you are expecting me to configure?
No, means I was just confused in between that. How you get that F0/0?
F0/0 is R2's exit interface, na?
Yes,
Because PC4 is residing in this network.
sir. From where are you trying to ping? From R1, you are
From
trying to
R1
ping
to
which
PC4.
PC4? Okay, then the exit should be F0/1, na? No.
Okay, I'll go
Sorry,
according to your knowledge.
F0/0. F0/0.
Wrong. If I'm wrong, let me go with your knowledge itself. So according to the destination network is what? 0.0.
0.0. Yes.
0.0. So 255.255.255.0.
F0/0. F0/0.
F0/0.
Hmm.
No, F0 says 0. No. 1 second. Ping. Which is the address we are trying to ping? Looking for that address.
210.0.1.
No, it will not take. It should be 0 bar 1. It should be 0 bar 1. Exit.
But sir, that 0 bar 1 is of R1's exit, na? Means R1's interface, na? That
You are telling the same thing, right?
yes, I was telling previously the same thing, that 172.16.0.0. 0.2, sorry.
0.2. Okay, 1 second.
Sir, see,
I'll just check with this. 1 second. I'll just check with this.
172.16.0.1.
Conf T. Okay, I'll just check with PC6 once. Okay, if it is taking or not, I'll just check with PC6. So just give me the root values for PC6. IP root.
192.168.1.0.
168.1.0.
255.255.0, and
Yes.
then the F0/1.
F0/1 exactly. F0/1.
बराबर. Or we can take 192.168.1.1.
Yeah, anything is fine.
Hop IP.
Anything is fine. Everything will work. 192.168. What is that F0 bar 1 IP address?
One PC6, na?
PC6. No, not PC6. Interface op IP. Op IP should be
1.1, na?
no. 200.10.0.2. Because this is the next hop, right? Next hop IP should be this one. I'm configuring with respect to R1. The next hop IP should be this one, right? The exit interface is this. Exactly, I agree. But the next hop IP should be this one.
Sir, how this one?
Sir.
That should be 19, because that is connected to 192 network, na? We are pinging PC6, na?
We have added that network destination network address here.
Yes, destination is added.
What is the rule? You tell me the rule. What is the rule that we are looking for? What is the rule? Syntax. What is the syntax?
Interface.
Either exit interface or next hop IP, right?
Yes.
Which is the
Yes,
next
sir.
hop
Yes, sir.
IP?
Yes, sir. Yes, sir. Right.
Which is the next hop IP? Yes. Anything is fine. Okay, either exit interface or next hop IP. So let me ping. What is the address of 192.168. What is the address? Can anyone tell me what is this PC6 address? Okay, let me check here itself. So 1.2.
1.2, yes.
Think R1 is taking some time or what?
Sir, see, not pinged.
It will ping. Wait.
Sir, I think taking the exit interface is more better than taking the hop IP.
Anything is fine. Anything is it is standard. It is a standard policy. It is declared by the routing principles itself. Okay, anything is fine.
Sir, for next hoping, hope it's F0/0, na?
Which one? This one?
Sir, for PC6.
For PC6, yes. So
Sir.
it is not this interface. It should be the router's exit interface.
Sir, it should be F0/0, na?
0/1.
0/1. This will be the interface.
Sir, we are pinging R1 to PC6, na? Right, na? That is
Yes.
the case, na?
PC6.
Sir, for that exit interface will be 0/1, right? Of R2.
0/1. Yeah, that is what I'm trying to do it
Yes.
here, right?
But
See,
if we are taking hop IP, then what should it?
hop IP should be this one. 200.10.0.2.
Sir,
See, show IP interface brief. Got it? You got this scenario? So what is the IP address of this interface? 10.0.2, right?
yes.
Yes. So what is the I'll just go back to the Lex and I'll tell you what's happening here. Okay.
Hop IP is at entry and exit is for interface.
Which one?
Sir, I was just clarifying that hop ID we take at the entry of the
Entry.
router. But
Okay,
for
let me do one thing. Okay.
Sir, only TCP4 is connected.
One second. Hold on. I'll figure it out. IP. So interface. I'm entering into this interface now. I'm entering into this interface. F0/0. Clear? Okay. So what I do is I'll just change this IP address to 172 itself. Might be it is not taking, so that is why it is giving some glitches. I'll just configure this for 255.255.255.0 and I'll just up this interface with this IP address. Wait. Let me check. Do show IP interface brief. Okay. So this interface, now it will work. One second. Which one we were looking for? R2, right? Fine. So what we do is, I'll just take this address, conf t. Okay, I'll just remove this and I'll just add F0/1 itself, exit interface, exit, ping 192.168.1.2, which is 1.1. Which is 1.1, PC5,
PC5, yes.
PC5 is 1.1. Okay.
Yes, sir. It is 1.1.
Let me check. Yes.
Yes.
Okay. The
it's
glitch is we have added two separate networks, na? Don't add the two separate networks.
Ah, sir. Only
that
one
clear?
should be there.
Okay. You can add, let me duplicate this. It also belongs to
Same network.
same network.
Ah, sir. That what creates the confusion.
Okay. So let it be, but this kind of situation will not be there. Don't worry. So it is a learning part. Okay, it's a learning part. Even you let us configure this IP address with respect to 1 second. We are trying to ping that R4, I mean PC4, right?
Yes.
Yes. Let me create this 192.116 dot 0 dot 5. I'll give. Okay. Some address I have given. Dot 0. Okay, I have not entered into the interface. Okay, sorry. So what is that interface? That interface. F0 bar 0. Okay, no shit. Is it to show IP interface brief? Okay. Okay, I'll
Sir, in
just
case
give
of no shut,
the routing because as it is an end user device, to show IP root, to show IP root. Okay, it has converted. Let me check now from R1 because as it is relying on one network, I think it should work, right? Okay, from R1 PC4 is also pinging up.
Yes.
Okay, let me check one more device 192.168.1.1 which is PC5, right?
PC5. Yes.
PC5. So how many static routes are created? I need to check it. Once again, it is not pinging. See, it's not pinging. Once again. Okay, it's pinging now. Fine. So show IP route. Show IP route. Is that all the networks are connected?
Yes, sir.
Is that all the networks are connected? How many networks are connected? 200. Okay, 200 is also directly connected. Okay, fine. We just detached it. Fine. Then which was the other network? Okay. So this is the direct network. Which is the direct network? 10.0 is the direct network for R1. And for, okay, fine. It is connected here. Can you check here? So, but it should create with 172.16.0.2 as of now. But it is showing still, it is showing with 200 dot earlier configuration it is showing. Are you getting it? Yes, it is quite confusion. One second. I'll clear before the wind up of the session. I'll clear it. Don't worry. Okay. See, guys, the only mistake what we did was, once again, give me a moment. The only mistake. Yes, guys. So the only mistake what we did was we added separate 200 area, right? 200 network. Yes. Do you agree? So once we detached it, so we are able Am I audible?
Sir, 4 times we have to do na that static connections.
No. How? No. How? Why four times?
Sir,
One is
suppose
for 192.
suppose we have to check the connections between PC5 and PC3. Then at that time the network destination network is 172, which belongs to PC3.
Which belongs to
Right.
PC3. I didn't get your question. 1 second.
Sir, suppose
Yeah, please repeat it, Chetan.
sir, if we have to check the connection, is there is any connection between PC?
Yeah, 1 second. It is loading. It is loading. Wait. It is loading. Yes. Can you please? Are you able to see my screen?
Yes.
Yes. Okay. Please go
Sir,
according.
if we have to check the connections between PC5 and PC4, sorry, PC5 and PC3. At that time, we have to means there is different destination network. Na, it PC3 belongs to 172.
Then you need to give the static route intelligence to R2.
Yes, and if we have to check the connection between PC5 and PC1, then PC1 belongs to 10.
PC1 belongs to 10. You also need to create one more static route for that.
For which is via R1. Na?
Which for R1 is the mutual one, right? Which is the router which is mutual to that network, and to the immediate next hop, it will be the configure router that can be connected to over static route.
Then syntax will be, suppose we have to make connection between PC5 and PC1. Then
PC5 and PC1.
PC5 and PC1. So in R2, we will go in R2. Then we use command IP route. Then destination IP will be 10.0.0.0. Okay.
Yes. 1 second. I'll do it. I'll do it for you. Wait. Conf T. Okay. IP route. So what is the destination network you are looking for?
10.0.0.1.
0.0.
Zero. Sorry.
Network.
Then 255.255.0.
0. Yes.
And then
F0 bar 0.
Yes, 0 bar 0 will be the
F0 bar 0 will be the exit interface, right?
Yes.
Okay.
So this will make the connection between PC5 and PC1.
Let me check. 1 second. Let me check. So let me try to connect from R2 itself. Okay. So what is the address of PC1? Can you please tell me?
10.0.0.1.
1. Okay. Let me check. It takes some time. Wait. It will take some time. R2 is having the knowledge of R1 completely. Let me check. Show IP route. Okay. It is showing that it is directly connected. Okay, how come it is directly connected? No, it is not directly connected. R2 is not directly connected. 1 second.
We have make static connection.
Yeah, no. Static connection also, it should not directly get connected, na?
Yes, sir. It is
via 172 it should get connected, right?
Yes.
172 it should get connected. Show IP route. 1 second. Let me check. Trying PC5. Okay. 1 second. I'll just check with PC5 also. This is the network we are looking for. So from PC5 we are checking it. Wait. So which is the destination network? 10 dot, right?
0.1.
1 second. Okay. R2. R2. Okay, it is not showing the table. according to me, the table is not displaying appropriately. 1 second. It should give the via. The administrative distance also should be given there. It is not popping up. Wait. If 0 bar 0, 0 bar 0, few times it happens. Wait.
Sir, but I am right now that if we have to access from PC5 to PC1 and PC3, then two times we have to make static connection.
2 times that you are asking about, I'm not aware of it. Which is the 2 times? I mean, according to you, which is the 2 times? I mean, where you need to configure it?
Sir, suppose PC5 is common, okay, and we have to means connect from PC5 to PC3. Then PC3 belongs to 172.
PC3 belongs to 172. Yes.
Then R2 should have knowledge of PC 172. Then there we make one static connection.
Have we not made any static connection for 172 as of now? Why we want to make static connection for R2 for R1? I mean, 172 is already directly connected to R2, na? See here, it is directly connected. C indicates directly connected.
Yes. First port of R2, that is F0/0.
Which one? No. Please repeat it.
172 is connected to F0/0, na?
Of course.
That network of R2.
Yes, exactly.
So just for means connecting to the network which belongs to 10 IP, for that we have to create static connection.
Okay, can you please give me the commands? So what you are looking for in R2? I'll you want me to configure in R2 or R1?
R2 PC5
Yes,
to
please.
PC1 make connection between PC5 to PC1.
Yes, okay, I agreed. PC5 to PC1, right? Okay, fine. For R2, what is the configuration you are looking for?
No, sir, not for R2. Just we have to IP route that destination.
That already it is given. I don't know. It is not taking. Accordingly,
Yes, sir,
I've given it. Accordingly, I've given it, but I don't know why it is not pinging up.
Then also it is not pinging. Success rate is 0.
One second. Let me check the network. Yeah, it is pinging. Okay, fine. See, 10.0.2 it is pinging.
But one not pinging. For one
is not pinging. Let me check
maybe
what is the issue with one.
will.
Yeah, there will be some glitches. That is what I was wondering.
Because if that is working for
two. One second. Oh, see here, 10.0.1 is not assigned at all.
Right.
Oh, see. So these kind of mistakes will happen. Sorry guys, we are not configured that part as well. So what we do is for PC1, I'll give .4. Is it okay? For PC1, I'll give .4.
Sir, give one only.
You want one only? I think one is given to this interface.
Which, sir? Okay.
I think one is already given to this interface. Let me give 4 or 5. Which one? I mean, out of one, you tell me which is the. Which is the one you want to give me? Give it to it. Give it to PC1.
Okay, give 4 then.
Give 4. Okay. Oh, we are not entered into the interface. Interface F0 bar 0. IP add 10.0.0.4 255.255.255.0. No shut exit 2WR. Okay, fine. I think
Now go to
which was the system you are looking for?
PC5 to PC1.
PC5 to PC1. So can you tell me the address now? 10.0.
4.
Means PC5, PC6. One second, let me check whether. Let me check. So which was the other address I gave to ping?
One only, na? Previously.
Which one? One second. Show IP interface brief. One second. It's okay, it is administratively up. I need to check here. Some glitches are there. To show IP interface brief. Okay. It is 10.4, huh?
Yes, sir. 10.4. But then also it is not pinging.
That is why I'm checking why it is not pinging. So there would be some glitches on these end user devices what we have configured. Let me check from R2 to PC1 once again.
Have we defined the PC1 with that 10.4? We do it initially like no IP routing.
Which one?
For the PC1, we have given
Yes,
the
sir.
10.0.4, na, but we have not done the first starting command like no IP routing.
IP, no routing. Check
It
once.
doesn't matter, I think so. Show IP. One second. Show IP root. Okay. It's converted.
Yes.
Okay. Let me ping 10.0.0.2 first. And I'll check it. Okay, 10.0.2 is pinging, right? From PC5, it is pinging.
Yes.
This is the address we are looking for. Okay, it's pinging.
It's pinging now.
Now,
Okay,
yes.
so thank you. See, that is what the troubleshooting is all about. Connectivity issue, missed configuration of end user device. All these are
Yes.
troubleshooting issues.
Sir, why that was happened?
Mhm.
That issue?
That issue because we were not able to. We didn't give this IP address for the configuration of 10.0.1. What you are asking about earlier. I mean, it was not configured on PC1 at all.
Yes.
No address was configured at all. Earlier, 10.0.0.1, whatever the address you said it, right?
Yes.
I think we have missed it. During configuration, we have missed it. Okay.
Maybe.
Yeah, there was a syntax error.
Yeah,
I am reminded that.
we had missed it.
That.
And sir, suppose we have to make connection between PC1 to PC6, then same na, the destination will be 192.
Can you see here? When I gave for PC1, this is PC1, okay? When I gave show IP interface brief, it was not up earlier. After
Yes,
I
yes.
configured 10.0.4, it is giving the up interface.
Yes.
Yes. Let me check with PC6 as well for your doubt clearing. 10.0.0.4, na?
Yes.
Yes.
Yeah. We are getting.
Yes. Yes.
Hello, sir. For that R1 and R2, that IP address will be same 172.16 for both at that junction.
Yeah, it can be the same. It can be the same. It's
And
something
previous-
like, no. I'll tell you, it's something like both are attached to common buildings.
Yes.
Okay. If you consider building 1, building 2, and building 3, building 2 is common to only one network.
Yes.
Is that clear?
Sir, one last
Sir,
question
but
for the
previous
team.
we took 200, sir.
The 200, just to go with the troubleshooting issue, I took 200, but it was not working, na?
Okay,
You-
means it's always same, right?
No.
Hello?
You can't configure that. I mean, the entirely a different network address with a different subnet mask. It will lead error. So that was the glitch.
Hello, Sanjay sir.
Yes, who is this?
Sir,
Chetan.
not understood, sir. Can you please repeat that one?
Which one?
Hello.
Which one?
Yeah,
Ajna?
that 172.16. Why we are getting-
Yes. See, 172.16.0.0, it's mutual for
R1 and R2.
for both the interfaces of the router.
Yes.
Is that clear? It is mutual for both the interfaces of the router. So
Okay,
if we are taking 200, no, let me explain this. If you are taking 200 network, right? Both are residing in one LAN, right? If you can see here, when we adapt a switch or any other devices, both are residing in one LAN, right? It is single LAN. So one single LAN can't be having two different IP addresses, right? So, sorry, two different network addresses, right?
Yes.
Yes. So it need to be configured under one network address umbrella.
Okay, so that's why we took that.
Yes. But the interfaces are different, but the gateway address is common to both the the entire network.
Okay. Understood, sir. Thank you.
Yes.
Hello, sir.
Hmm.
As R1 and R2 are connected to 172, that which is common, so PC1 and PC2 can we access PC3 and PC4 without static, and also PC5 and PC6 access PC3 and PC4 without static connection, right?
Yes. Let me check
But-
it. Let me check it. Wait. Okay. Fine. One second. R1 is okay. PC1 to PC3. You want to check it?
Means R3 to R4, R5.
PC1 to PC3, na?
Hmm.
So what is the
172.
PC3 address?
172.16.0.1.
0.1 or what? I mean, just check it and let me do it.
0.
1.1. Okay. Fine. Because again, it will throw an error. Okay.
Same, correct, 0.1.
Yeah.
Yes, it is working, see.
Yeah, it will work, man. Because both are connected to one common router, na?
Yes.
Yes.
So it is necessary just for only if 10 wants to access 192 and 192 wants to access 10.
Yes. 192 want to access 10. You need to create static route. We created, no?
That what I'm saying, that static route is needed only when 192 wants to access 10 and vice versa.
See, very simple funda here. Whenever there is a directly connected routers are there, you need to create static route for that network.
Yes.
If the network is completely isolated from this router, see, R1 is completely isolated from 192 and R2 is completely isolated from 10.
Yes.
Right? So for these two routers, vice versa, you need to add the static route accordingly.
Yes. Right.
Is that clear? Now
Yes, sir. This example clears all the doubts.
Yes. So we had so many issues here, right? So that is why, see, in the legs part, even till today, I didn't experiment that legs exercise. So I thought of taking two different networks. I mean, two different network address. So it gave some glitches. You can, out of that error, you will come to know, right? Okay, fine. Under one umbrella, it should exist. Yes or no? One single LAN should exist only under one network address umbrella. It can't share two different network addresses. It's something like that. Okay. Yes. Any doubts?
No, sir. Thank you so much. We have asked really lots of questions to you.
No. I'm here to solve that because even today, even I'll also learn, na.
Yes,
I'll be. I mean, if PC1 was work, I mean, I made that mistake. I didn't made it administratively up. So I was keep on pinging it, and we wasted a lot of time on it.
Yes, sir. Because still we are not unmuted. In chat we can't means express our questions properly. So
No. Whenever you feel doubt, you can express your questions. No issues at all. Okay. See from R1 is isolated to which network? See here.
192.
Yes. Don't go with this because it was an earlier configuration. Don't go with this. Okay. 192, right? Via which network it is reaching? 200, because we configured that network. No, it is taking that discipline itself on that route itself. So this is called as AD value. I'll tell you tomorrow what is this AD value is all about. Okay. So on single day, if I input everything, you will be overwhelmed. So don't worry. Tomorrow we'll discuss on default routing, AD value, and dynamic routing principles. Is that clear?
Sir, one more doubt is there.
Yes, Dishu. Yes, please.
So we have already cleared that one PC cannot be connected to two routers. But here
No.
PC3 is connected
Please
to two
make a
routers.
correction. No. One PC can't be connected
Network
to
is
routers.
same, yes.
Network will be same. Network address can't be two different networks can't be given to one LAN. Make that correction.
So sorry, sir. Can you repeat it?
Two network addresses can't be given to one single LAN.
Oh, okay.
Yes. Yes. What is your question now? Yes. Please, if you have got any doubts, please go ahead with your doubts. One LAN can take only one network. Exactly. One single LAN can take only one network, not two networks at a time.
In reverse, we can also say that one LAN can connect to two routers, but network should be same.
One LAN can connect to, yes, one LAN can connect to multiple routers, yes.
But network
Multiple
should be
routers.
same for.
But the network address should be the same.
Okay, oh, yes.
If network's address are changed, there won't be any communication. See, don't get confused with network address, people. I'll just take only 2 minutes of your time, and we'll end for the day. Okay, I'll just 1 second. You got the roll numbers in your classrooms, right? Roll numbers in your school. You got a roll number, right? Everyone, yes or no? Yes. So this roll number, for example, 1 to 70 was the roll number, right? 1 to 70 was the roll number. Teacher identifies this class only with respect to this roll number. For example, let us take something like this. So, okay, fine. This he will be the representative of that entire network. Is that clear? Starting from 2 to 69. From 2 to 69, he will be representing the entire class. 70 is what? Broadcast. So whichever the information teacher want to announce to the class, he will be the announcer. Is that clear? So this is how the network address and broadcast address in between the hosts are mapped. So if this network address is changed, then teacher will not be able to identify which class it is. Is that clear? Is the concept is clear to you? Yes. Yeah. Tomorrow what we'll do is we'll have a recap on static route. And later after we'll jump into the dynamic routing. Is that clear? Dynamic routing. Yeah, we'll have a recap on it. No issues. I'll take only 15 minutes. I'll explain you correct thoroughly. With the previous example itself, I'll explain. Don't worry. Okay. Okay. Thank you. Thank you all. I'm really happy that you people have got a lot of doubt. I'm really happy.
Thank you
Please
so
come
much,
out
sir,
with this
for
doubt.
clearing all the doubts.
No. It's our duty to clear the doubts. Thanks. Okay. Fine. So let us have good evening. Okay. Stay safe. Yes.
Notepad, sir, once share the notepad.
Yes, Zaid, please. Zaid, are you there?
Yes, sir.
Yes. Have you got any doubt, Zaid?
No, I was just telling sir to show the notepad once.
Notepad. Okay, guys, you see that this notepad will not serve anything. Okay, fine. If you want me to share, I'll share it at the last. Don't worry.
Okay, sir.
Okay.
Thank you.
Yes. Online source is Lex. You can refer Lex. Lex is like a Bible. You can refer it. It will give you everything. Yes, Boya. He's into some other conversation. Sorry, guys. Okay. Happy time, guys. We'll connect tomorrow. Okay. Thank you. Thank you, everyone. Thank you.